Good evening, all. Welcome to today's live discussion session for the course Soil Mechanics Geotechnical Engineering I. I am Reshma, research scholar from IIT Madras. So I shall share my screen now. Hope it is visible for you. All right.
Yes, madam. Yes.
Oh, okay. So we'll move on to the first question. So the first question for today's session is: the variation of earth pressure with wall movement is shown in figure. The position of the active and passive earth pressures are respectively indicated in the figure by the points labeled. So, which of the points in the figure represents active earth pressure and passive earth pressure? You can type in your answers in the chat box. So, which point represents active earth pressure and which point represent passive earth pressure? Option A 1 and 2, option B 2 and 3, option C 3 and 4, option D 1 and 4. Okay, the answer in the chat box is option D. So yes, correct answer is option D. So when we look at this figure, we can see that the point A or point 1, as in the question, represents passive earth pressure. That is when the movement is away from the fill. And point C represents passive earth pressure when the movement is towards the fill. Whereas the center point, that is B, represents the earth pressure at rest. That is when there is no movement at all. Okay, so moving on to the next question. The appropriate expression to calculate the value of earth pressure at rest from the following is. So, which is the equation for calculating earth pressure at rest? Option A 1 plus sine square phi. Option B 1 minus sine square phi. Option C 1 minus sine phi. Option D 1 plus sine phi. Okay, I have an answer in the chat box. That is option C. Yes, correct answer is option C. That is the equation for calculating earth pressure at rest is K0 is equal to 1 minus sine phi. All right. Now, question number 3. The failure plane behind a vertical wall in the passive pressure case is inclined to the horizontal at. So, in the case of passive earth pressure, the failure plane behind the vertical wall is inclined to the horizontal at which angle? Option A 45 degree minus 5 by 2. Option B 45 degree minus 5. Option C 45 plus 5 by 2. Option D 45 plus 5. Yes, I have the answer option C, but the correct answer is option A, that is 45 minus 5 by 2. The failure plane behind the vertical wall in the passive pressure cases having an angle 45 minus 5 by 2 with the horizontal. Okay, so the next question is: as per Rankine's theory, the wall friction is option A 0, option B equal to 5, option C greater than 5, option D less than 5. So, okay, I have the answer in the chat box as option A. Yes, as per Rankine's theory, the wall friction is 0. So, what is Rankine's theory? Rankine's theory actually was put forward by William John Macon Rankine in the year 1857. It is also known as maximum normal stress theory. So, it provides the stress field solution. That is, it predicts the active earth pressure as well as passive earth pressure. As all other theories, there are some assumptions or limitations for the Rankine's theory also, whereas it considers wall as frictionless. So, that is why we have the wall friction is zero. So, one of the assumptions adopted in the Rankine's theory is that the wall considered, the retaining wall considered, is frictionless. Another assumption is soil is cohesionless, soil wall interface is vertical, failure surface on which the soil moves is planar, and resultant force is angled parallel to the backfill surface. So, all these assumptions are considered while formulating the Rankine's theory. So, the friction or wall friction is zero in the case of Rankine's theory. Okay, so moving on to the next question. Consider the following statements. So, statement 1, Coulomb's earth pressure does not take the roughness of wall into consideration. Sentence 2, Coulomb's theory gives less accurate results when compared with Rankine's theory. Statement number 3, any movement of retaining wall away from the fill corresponds to active earth pressure condition. So we have three statements, and the correct statements from the above is or are option A, 1 alone is correct, option B, 1 and 2 are correct, option C, 2 alone is correct, option D, 3 alone is correct. So we have three statements. The first statement is that the Coulomb's earth pressure does not take the roughness of wall into consideration. Second statement is that the accuracy of the results provided by Coulomb's theory is less than the that provided by Rankine's theory. And statement number 3, any movement of retaining wall away from the fill corresponds to active earth pressure condition. Okay, I have the answer in the chat box as option D. So let's see which is the correct option. Yes, correct option is option D. So in Coulomb's theory, it assumes that wall surface is rough. That is, it considers the roughness of the wall, or it considers wall has a friction value, unlike the Rankine's theory where wall friction was considered as zero. So other assumptions of Coulomb's theory are soil is isotropic, homogeneous, and has both internal friction and cohesion. Rupture surface is a plane surface. Backfill is planar. That is, it may be slope, but it is not irregularly shaped. That was the assumption considered. Then, third assumption was the friction resistance is distributed uniformly along the rupture surface, and the corresponding soil to soil friction coefficient is given by tan phi. Fourth assumption is failure wedge is a rigid body undergoing translation. And the last assumption is there is wall friction. That is, as the failure wedge moves with respect to the back face of the wall, a friction force develops between the soil and wall. And the friction angle is usually termed as D. Also, the failure is a plane strain problem. That is, consider a unit interior slice from an infinitely long wall. And coming to the second statement about the accuracy, Coulomb's theory was actually developed much before Rankine's theory. As per Rankine's theory, the Rankine's theory is much simpler to adopt, so it has become popular among the engineers rather than Coulomb's theory. But the fact is that Rankine's theory is less accurate because it has several simplifying assumptions. For example, it doesn't even consider the wall friction. So, in effect, Coulomb's theory gives more accurate values of lateral earth pressure and all the variables affecting lateral earth pressure are duly considered, unlike in Rankine's theory. In the case of Rankine's theory, most of the complex parameters are simplified for easiness, and that's why it is popular among the engineers, not because it is more accurate. Okay, now coming to the next question. If the coefficient of active earth pressure is zero point 0.2, then the coefficient of passive earth pressure is option A 1 by 5, option B 5, option C 1 by 2, option D 2. Okay, I have got an answer in the chat box as option B. So let's see which is the correct answer. Correct answer is option B, that is 5. So here we are given that the coefficient of active earth pressure denoted by Ka is equal to zero point 0.2. Now we know that coefficient of active earth pressure is given by the equation 1 minus sine phi by 1 plus sine phi. And coefficient of passive earth pressure is given by 1 plus sine phi by 1 minus sine phi. So, that is in turn the reciprocal of coefficient of active earth pressure. So, here in the question we are given that the value of coefficient of active earth pressure is zero point 0.2. So, taking the reciprocal, coefficient of passive earth pressure is equal to 1 by zero point 0.2, which is equal to 5. Okay. Moving on to the next question. The intensity of active earth pressure at a depth of 11 meter in dry sand with an angle of shearing resistance of 35 degrees and unit weight of 18 kilonewton per meter cube is. So we are given soil sample of dry sand with angle of shearing resistance 35 degree and unit weight 18 kilonewton per meter cube. We need to determine the intensity of active earth pressure at 11 meter. Option A 53.65, option B 65.17, option C 78.18, option D 95.44. Okay, I have got an answer in the chat box as option A. So let's see which is the correct option. Yes, correct option is option A. So here in this question we are given the sand sample with angle of shearing resistance 35 degrees and unit weight 18 kilonewton per meter cube. We need to determine the intensity of active earth pressure at a depth 11 meter. So, intensity of active earth pressure is given by Ka gamma h. Now, Ka is the coefficient of active earth pressure, which is equal to 1 minus sine phi by 1 plus sine phi. Here, phi is given as 35 degrees. Substituting in the equation, we get coefficient of active earth pressure Ka is equal to 0.271. Now, in the equation for intensity of active earth pressure, We have gamma and H. The values are directly given in the problem. Substituting in the equation for intensity of active earth pressure, we have PA is equal to 0.271 into 18 into 11 Ka gamma H, which is equal to 53.67 kilonewton per meter square. Hope that's clear. Moving on to the next question. A 4.5 meter high masonry retaining wall has to retain a backfill of sandy soil having a unit weight of 18 kilonewton per meter cube and an angle of internal friction of 35 degrees. The surface of the backfill is inclined at an angle of 10 degree to the horizontal. The active earth pressure coefficient for the wall is option A 0.282, option B 0.354, option C 0.441, and option D 0.478. So here in the question we have a masonry retaining wall of height for 4.5 meters. It is retaining a backfill of sandy soil with angle of internal friction 35 degree and unit weight 18 kilonewton per meter cube. Also, the inclination of the back surface of the backfill is 10 degree to the horizontal. We are asked to determine the active earth pressure coefficient. I have got an answer in the chat box as option A. So let's see which is the correct option. Yes, correct option is option A. So here we are given that the height of the masonry retaining wall is 4.5 meter, which is retaining backfill of sandy soil, and the unit weight of sand is 18 kilonewton per meter cube. Angle of internal friction is 35 degree and inclination of the backfill with horizontal, that is beta, is equal to 10 degree. So we know that active earth pressure coefficient for the wall is given by cos beta into cos beta minus square root of cos square beta minus cos square phi, the whole divided by cos beta plus square root of cos square beta minus cos square phi. So here beta and phi are given in the question. Substituting, we have cos 10 into cos 10 minus square root of cos square 10 minus cos square 35 by cos 10 plus square root of cos square 10 minus cos square 35, which is equal to 0.282, that is option A. Hope it is clear till this question. Moving on to the next question. A 4.5 meter high masonry retaining wall has to retain a backfill of sandy soil having a unit weight of 18 kilonewton per meter cube and an angle of internal friction of 35 degrees. The surface of the backfill is inclined at an angle of 10 degree to the horizontal. So we can see that the sample given is exactly the same as the previous problem. There we were asked to find out the coefficient of active earth pressure. Here we are asked to determine the magnitude of active thrust in kilonewton per meter on the wall. Option A 64.34, option B 46.57, option C 31.64, option D 51.39. All the values are similar. Only thing is here we need to determine the magnitude of active thrust. Okay, I have got one answer in the chat box as option D. So, yes, the correct answer is option D. So, here we are given the height of the masonry retaining wall as 4.5 meter. The unit weight of sand in the backfill is 18 kilonewton per meter cube. Angle of internal friction phi is 35 degrees. And the inclination of the backfill with horizontal is 10 degrees. So, as in the earlier problem, estimating the active earth pressure coefficient for the wall, we have Ka is equal to cos beta into cos beta minus square root of cos square beta minus cos square phi, the whole divided by cos beta plus square root of cos square beta minus cos square phi. Substituting as in the earlier problem, we have Ka is equal to 0.282. Now, in the current problem, we need to determine the magnitude of active thrust. The equation for which is half Ka gamma h square. So, substituting, we have half into 0.282 into 18 into 4.5 square, which gives us a value 51.39 kilonewton per meter. So that is the last question for today. Hope all the questions were clear to you. If you have any doubts, you may please ask.
Madam, I have one doubt, madam.
Sure.
Uh, regarding active earth pressure and passive earth pressure.
Okay.
So active earth pressure means generally we will construct the retaining wall across the some place to store the earthfill material, right?
Yes.
So obviously that earthfill always creates the pressure on the wall that is called as active earth pressure.
Uh, Actually, the thing is like active earth pressure comes into action when there's a movement. Typically, when there's a movement, when see when the retaining wall and the what do you call the backfill is at rest, we don't have a active or passive earth pressure case, right? That time
Yeah.
we
If any one of these is there, that is failure.
yes we if there's a movement.
Yeah. That's why that is comes under failure. So generally,
Mm.
in general cases, existing is only at rest only.
Yes, that should be
But
the typical case, or that should be the what do you call favorable case.
favorable case is at rest.
Yes.
the, for the possibility case, we is only the active earth pressure. How it will be passive earth pressure means,
Mm,
that's not my doubt, madam.
mm,
So generally, the backfill soil material is
mm.
always trying to give the pressure on the wall, retaining wall. That
Yes,
is obviously. But
yes.
how the retaining wall will give the pressure on the, that is not our purpose, and that is not how it will be justified. I don't understand how
Uh,
the retaining wall gives the pressure on the backfill.
okay, you are asking me how the retaining wall is exerting pressure on the backfill.
Yeah, exactly. That how it is it that I can't understand.
No, actually, the active earth pressure case is the case in which earth is exerting a force on that particular retaining wall.
Yeah, exactly,
And
exactly.
that wall will have a tendency to move towards that
Uh,
excavation.
Away from backfill towards
Yes, yes,
okay,
towards
right,
the that empty excavated portion.
right.
Yes.
That is okay. That is
Yes, when
clear.
when it comes to passive earth pressure, that is
Hmm.
where the retaining system is like trying to exert, like it is trying to fall over this backfill, that is it is failing. The stability is questioned there, the stability of the retaining wall gets questioned, and it is having a movement towards the backfill, it is exerting a pressure in the opposite direction, exerting a pressure in the sense that wall is failing towards the backfill.
No, that's what my doubt, madam. Actually, we are constructing the retaining wall, so
It
the
should, yeah, it should
to store the
support.
to store the soil. So the soil
Yes,
is always creating pressure on the wall means that
yes.
is okay.
Mm.
But how this wall can create the pressure on the backfill?
That maybe where like different conditions can happen. For example, if you check in the case of what you can say, if there is a waterlogging situation in the other side, excavated side,
Hmm.
that can have a effect on this like negative effect on this wall, right, like causing the wall to have a like movement in the other direction, maybe that pressure is more. Or if there is a if the retaining wall is constructed for in the case of a coastal structure,
Hmm.
um, in such cases there can be um, a movement of the wall towards the what do you call the
Towards
backfill.
towards back
Yes,
towards backfill.
yes, that can happen like only when unfavorable situations occur, and this mm, wall gets another force from the other side, because usually the other side is empty, right, like it's
Yeah.
excavated region, yeah. But
Yeah. Yeah.
when it has some external forces acting from there, for example maybe a sudden hit from a vehicle or kind of, or a wave hit, anything like that.
Okay.
Yeah, that is what I know. Or else then which what example I can tell you. No, that is the
But I
possible.
didn't hear the clear. Okay. Anyway, somewhat I got it, but still the purpose of the retaining wall is that we are not going that wall is not going to give the
Yeah,
pressure on
that
the
means
backfill.
that wall have failed, like that is definitely correct.
Of course,
Yeah,
both active and passive both are failed only.
yeah,
Uh, that's okay, madam. Okay,
yeah, some unfavorable condition can happen in this side also, that is what I have understood. Or
okay,
else maybe if the if there is something I don't know, maybe some foundation issues are there in the retaining wall and just having already a lineage towards the other side while construction itself, that can also cause that movement. Or kind of earthquake kind of situations can also cause that movement
okay,
towards
okay,
either side, yeah. Okay,
okay, madam.
so all right then, we'll meet during the next discussion session. Okay, thank you.
Thank you, madam. Thank you.